Now let's go ahead and try some word problems here. These are some problem-solving techniques that you will use throughout the rest of algebra. And the first is we're not solving anything here. We're just learning how to set up the problem. So we are not solving. So technique 1, when you have the sum of two numbers. So when would you need the sum of two numbers? This is if you're having a board cut into two pieces. This is if you're having an auditorium and there are children's seats and adult seats, two different categories. This is here if we have a class and we have different students and we have, let's say, guys and girls, or any category you want to put in. Two different categories where they're added up together to make a whole. So if the sum of two numbers is 50, this is your technique. If the total is 50, the total minus x is one category, and x is the other category. So let me give an example. If the total of two numbers, let's solve this actual problem here. If the total of two numbers is 50, number 1 is going to be represented by x, and the second number is going to be represented by 50 minus x. That's your answer for this. Write an expression representing the other number. Here's one number and here's the other number. We go over this a lot, especially in the face-to-face class, and then, when it comes time to it, students forget this technique. But it's very important. Here, if we had, for this example, for the number of children's tickets would be x, and the number of adult tickets would be, let's say there are 100 altogether. 100 minus x. So let's say we have 28 students in the class. The number of girls would be x, and the number of guys would be 28 minus x. So this technique is something you use all the time if you have the sum of two numbers or a category is broken into two parts, two subcategories, and you're given a total. It's always x and the total minus x, x and the total minus x. All right, so why don't you try practice 9. And another type of problem, so the sum of two numbers or finding the total number of tickets when you've got two different categories, or finding the total number of students in a class when you've got two categories, that's one type of modeling problem. Here's another, and that's consecutive integers. Consecutive even integers or consecutive odd integers. So first of all, consecutive means in order. So consecutive integers would be like 5, 6, 7, 8. Those would be 4 consecutive integers. Or maybe -8, -7, and -6. Those would be 3 consecutive integers. Consecutive even would be consecutive even integers like 10, 12, 14, 16, 18. That would be 5 consecutive even integers. And do you notice these go up by 1, whereas your consecutive evens go up by 2. 10 plus 2 is 12. 12 plus 2 is 14. 14 plus 2 is 16. 16 plus 2 is 18. And your consecutive odd numbers also go up by 2. So let's say 9, 11, 13, and 15. Those would be 4 consecutive odd integers. Notice consecutive evens go up by 2 and odd numbers go up by 2. Basically, you're skipping a number. So if we're not going to solve this problem, we're just going to practice modeling. If x is the first of 3 consecutive odd integers, express the first and the third. Okay, so for consecutive type problems, you're going to create placeholders. This is going to be the first of the 3 consecutive odd. This is going to be the second of the 3 consecutive odd, and this is going to be the placeholder for the third. If we're finding 3 consecutive integers, you're going to have 1, 2, 3. If we were finding 5, we would have 1, 2, 3, 4, 5. If we were finding 2, you would just have a 1 and a 2. The number of placeholders you have is based on the number, how many numbers you're trying to find. The first number is always x. Always. Whether you're finding consecutive, consecutive even, or consecutive odd. The next number, if the little word odd is in there, or if the little word even is in there, you're going to add 2. So this would be your first odd number, and the next one would be whatever that one was plus 2, and the next one would be whatever that one is plus 4. So this is your answer for this problem. But let's go ahead and do another example, because they all start looking the same once you get a little bit of practice. What if I wanted 5 consecutive integers? I do not have the word even. I do not have the word odd. They're just consecutive integers. That's the first, that's the second, that's the placeholder for the third, that's the placeholder for the fourth, and that's the placeholder for the fifth. The first of 5, the second of 5, the third of 5, the fourth of 5, and the fifth of 5. Your first one is always x. And consecutive integers go up by 1. X plus 1, x plus 2, x plus 3, x plus 4. That's how you would model 5 consecutive integers. Well, let's go back here. This is how you would model the first, the second, and the third. But look here, the question was express the sum of the first and the third. Well, the first is x, and we want to add the first and the third. The third is x plus 4. This is the first of our 3 consecutive odd, and this is the third of our 3 consecutive odd. So the sum of those, x plus x, would be 2x plus 4. There's the first, and there's the third, so when we sum those up, we'd want to combine our like terms.